We're finishing the notes that we started during period 2 this morning. And I believe we were on the second to the last page, and we need to start with this one. Whoops, sorry about that. All right, tangent squared theta equals 2 minus tangent theta. Since I've got a squared term, I think I'm going to set it equal to 0, and hopefully it'll factor. So I'm going to add tangent theta to both sides, and then I'm going to subtract 2. Now, if you want to do the x substitution and let x equal tangent theta, then you'd have x squared plus x minus 2 equals 0, and you could factor it that way. So what would that be? X plus 2 times x minus 1. So this is going to be tangent theta plus 2 times tangent theta minus 1 equals 0. So the first factor gives me tangent theta equals negative 2. The second factor gives me tangent theta equals 1. Let's start with the easy one first. From 0 to 2 pi, what quadrants have a positive tangent? Well, 1 and 3. What angle in quadrant 1 has a tangent of 1? Well, that's pi over 4. So from this one, we get pi over 4. And then we'll have a pi over 4 reference angle down into quadrant 3. So I need this angle. So what's that? Pi plus pi over 4. So that's 5 pi over 4. So here are 2 of your answers. Now let's go over here. What quadrants have a negative tangent? Well, that's going to be quadrants 2 and 4. But I don't know an angle that has a tangent of 2 or negative 2. So I'm going to have to take the tangent inverse of both sides. So theta equals tangent inverse of negative 2. You're going to go to your calculator. When you do this on your calculator, you get theta equals negative 1.107. Now, because that's negative, it's not from 0 to 2 pi. You got to decide what quadrant it is in. Well, if we go back over here, notice that's a negative angle, which means you're going clockwise. This would be negative pi over 2, and this would be negative pi. This is negative 3.14. Again, we're going clockwise. This is about negative 1.57. So negative 1.107 is going to be in this quadrant. That's good, but it still doesn't carry a name of 0 to 2 pi. So here's what I'm going to do. I've got a reference angle. Remember, reference angles are always positive. So I need this angle right here, which will be 2 pi minus 1.107. So for this one, I get theta equal 5.176. Now remember, tangent is also negative in quadrant 2. So I need a reference angle of 1.107 in quadrant 2. So to find this angle, it will be pi minus 1.107. So your other angle is 2.035. So there are 2 of the answers, and there are the other 2 answers. Last page. Often the trig equation cannot be factored. When we encounter this problem in algebra, when we're solving equations, we use the quadratic formula. As a review, let's write this formula, and then we'll solve that the next equation keeping this formula in mind. All right, remember the tune, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. You say, how do I use that with trig? I'll show you. All right, so let's look at this one. I'm going to distribute cotangent theta. So it's going to give me cotangent squared theta plus 3 cotangent theta equals 1. I'm going to set this thing equal to 0. So I'll have cotangent squared theta plus 3 cotangent theta minus 1 equals 0. Now the issue is that won't factor. So one of the things we can use is quadratic formula. But we're not going to say x equals. It's this equals. So you're going to say cotangent theta equals. Now let's look here. A is 1, B is 3, and C is negative 1. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So what does that give us? Negative 3 plus or minus the square root of, what's that, 9 plus 4, 13 over 2. Okay, we're going to have to erase all this for now because I'm going to need a lot of room. So now let's look at what we've got here. We've got cotangent theta equals negative 3 plus the square root of 13 over 2. And we've got cotangent theta equals negative 3 minus the square root of 13 over 2. Well, I don't even know what those are. I don't know. So what I'm going to do is I'm going to go to my calculator and get an approximation for that. Actually, no, I'm not either. I'm going to go in and do this. Cotangent inverse. And you think, well, how do I do cotangent inverse, Miss Stinnett? Well, what if we did this? What if we said tangent theta equals 2 over negative 3 plus root 13? Now I can do tangent inverse. So theta equals tangent inverse of 2 over negative 3 plus root 13. Now I'm going to stop the recording while I do that on my calculator. I get theta equals 1.27, that's a really bad 2, 1.277. Okay, 1.277 radians is going to be in quadrant 1. Now here's the thing, if I go back and I actually run that on my calculator, what do you get? This thing right here is positive. Now you think, well, you should have known that, Stinnett, because 13, square root of 13 is somewhere between 3 and 4. So negative 3 plus a number between 3 and 4 is going to be positive. And 2 divided by a positive number is positive. So I need angles in quadrants 1 and 3. Theta equals 1.277 is in quadrant 1, so that's one of my answers. Then I need that reference angle into quadrant 3. So it's that pi plus 1.277. Run that on your calculator. $4.418. There are the two angles that answer this part. Now let's go over and find the angles that answer this one. So we know that tangent of theta is 2 over negative 3 minus root 13. Well, I know that denominator's negative, and 2 divided by a negative number is negative. So here I'm going to have two angles that have a negative tangent, which will happen in quadrant 2 or quadrant 4. So theta equals tangent inverse of, Okay, take a minute and go to your calculator and let's see what we get there. I got theta equals negative 0.2, that's just bad, negative 0.294. Now that's not between 0 and 2 pi. I know that's in quadrant 4. That's where I wanted one of my answers. So we're going to use that as the reference angle. In quadrant 4, so I need this angle. So it'll be 2 pi minus 0.294. I get 5.989. Now that's the angle in quadrant 4. Now I need an angle in quadrant 2 with that same reference angle. .294. So what's that going to be? Pi minus 0.294? So my other angle is 2.848. So there are two of my answers. And, oh, I erased the other two, didn't I? Yeah. Okay, now we need to go back and erase the stuff that I wrote over. Well, come on. All right, we've got two more to look at. Solve the equation below utilizing sum and difference and or double angle identities. Well, okay. For sine theta, cosine theta, I don't have a formula for that. What I do have a formula for is 2 times 2 sine theta cosine theta. Now, if I divide both sides by this 2 right here, then look what I've got. 2 sine theta cosine theta equals negative root 2 over 2. But this is sine of 2 theta. Now remember, since this right here is 2 theta, I'm going to have to make 2 revolutions around the circle. All right. Negative root 2 over 2. Sine is negative in quadrants 3 and 4. So let's talk reference angle in quadrant 1. What angle in quadrant 1 has a sine of root 2 over 2? Well, that'll be 45 degrees or pi over 4, right? So I need a 45 degree or pi over 4 reference angle into quadrant 3 and into quadrant 4. So I need this angle, which is pi over 4. So 2 theta is going to equal 5 pi over 4. And I need this angle, which is 2 pi minus pi over 4, 7 pi over 4. So that's my quadrant 4. Well, hang on a minute. Because what I need is 2 passes around the unit circle, don't I? Okay, so let me think about this for a minute. I'm going to turn this off and make sure I do this right. Okay, everything's good. Now what I've got to remember to do is do 2 passes around the unit circle. So let's go back to the red angle. I need this one, which is 5 pi over 4, plus another 2 pi. So that's 5 pi over 4 plus 8 pi over 4. That's 13 pi over 4. Then I need for the green angle, I need to go around not once but twice. So 1 and then another one. So that's the 7 pi over 4 plus 2 pi. So 7 pi over 4 plus 8 pi over 4 is 15 pi over 4. So now I've got theta equals, and I'm just going to divide all these by 2, which is the same as multiplying by a half. And there we go. There are our answers. Okay, we got one more problem to do. So I'm going to pause and erase. 2 cosine x minus 2 sine x equals square root 3. Well, I'm going to factor out that 2. So that's going to leave me with cosine x, which is that, minus sine x. I don't think I want to do it that way. I could, hang on a minute. I'm going to stop and think. No, I am going to do yeah, I'm going to do that. So it'll be cosine squared x minus sine squared x equals root 3. Now here's the thing. That is a formula for cosine 2x. So this is 2 times cosine 2x equals root 3. So I'm going to divide by this 2 right here. I'll have cosine of 2x equals root 3 over 2. Now remember, I've got to make 2 passes because my coefficient here, or my argument, is 2. All right, I have a positive cosine, and positive cosines happen in quadrants 1 and 4. So what angle in quadrant 1 has a cosine of square root 3 over 2? That would be pi over 6. But if I made another full pass around the unit circle to get back to pi over 6, what would that give me? Pi over 6 plus 2 pi. That's pi over 6 plus 12 pi over 6 is 13 pi over 6. Now I need to go down to quadrant 4. I have a reference angle of pi over 6. So in quadrant 4, that would be two pi minus pi over 6. So what would that give me? 11 pi over 6. Plus I need to go around one more full time. So I need to add 12 pi over 6 to that. So I think that gives me 23 pi over 6. So x equals, I'm dividing all by 2 or multiplying by a half. Pi over 12, 13 pi over 12, 11 pi over 12, and 23 pi over 12. Again, remember, if you are uncomfortable, if you're just not sure, take any of these angles, 23 pi over 12, put it back in here, use your calculator, make sure that this works, make sure that that equation is true. But it's going to work. You'll be fine. And that's the end of the lesson.